Hey everyone, welcome back to my channel Beaker and the Board. Today's class is about the functional group. So in my previous videos I have taught you how to write the IUPAC nomenclatures of alkanes, alkenes and alkynes. What have you seen there? The common feature in all of them is that all the alkenes or alkanes or alkynes are simply hydrocarbons. For example, if I say about the C2H4. This is ethene or ethylene. It is like this carbon-carbon double bond. If I speak about ethyne or acetylene, it is again having carbon-carbon triple bond. And if I say about ethane C2H6, it is having a carbon-carbon single bond. All of them, the common feature in all of them is that they are having only carbon and hydrogen atoms. So, alkanes, alkenes and alkynes come under the category of hydrocarbons, in which the alkanes have carbon-carbon single bond, alkenes have carbon-carbon double bond, and the alkynes have carbon-carbon triple bond in them. Today's class is entirely different from the previous classes. Please consult the previous videos if you haven't done it yet, so that you get to understand, you get a clear view of how to write the IUPAC nomenclatures of those compounds. So what are functional groups? Functional groups are some heteroatoms, are some other groups or other atoms which replaces hydrogen atom of a hydrocarbon. For example, see in this reaction I have shown you, it is not a reaction, it is just a general representation. In this compound I have shown you methane CH4. This is methane CH4, in which the carbon atom is bonded to 4 hydrogen atoms. What is shown here, if one of the hydrogen atoms is replaced by another group or another atom, then a completely different compound is formed. For example, it is CH4. When hydrogen is replaced by X, minus H means hydrogen is getting replaced with X. So what do we get? We get something like this, CH3X. Now this X can be any group. You have different types of functional groups which I will be discussing in this class. See, X can be OH, alcohol functional group, can be aldehyde functional group, can be carboxylic acid functional group, etc. There are many functional groups. So, what happens when one or more hydrogen atom, it is not necessary that every time only one hydrogen is replaced. Sometimes more than one hydrogen can be replaced. So when one or more hydrogen atom is replaced by another different group or different atom, such that the newly formed compound, that means CH3X, the newly formed compound has completely different physical as well as chemical properties from the parent hydrocarbon. For example, in this reaction, the parent hydrocarbon is CH4. Parent hydrocarbon means the hydrocarbon from which the other compound is generated. The hydrocarbon whose hydrogen atom is replaced with another atom so that a new compound is generated. CH4, methane, it is under normal conditions, at room temperature, under normal conditions, methane is a gas and it is completely insoluble in water. It does not dissolve in water. But on the other hand, if suppose this X is replaced, suppose X is OH. If suppose X is replaced by OH, then CH3OH will be called methanol. In this class itself, I will be teaching you how to write the IUPAC nomenclatures of compounds having functional groups. Suppose if X is OH, that means if the compound changes from methane, that means The parent hydrocarbon is methane, and when hydrogen atom is replaced by OH, methane to methanol. See, the properties are completely different. While methane is a gas, methanol is a clear liquid. While methane is completely water insoluble, methanol is water soluble. Methanol dissolves in water completely. I have discussed only these two physical properties. It is not only these two. All the properties, even the physical and all the physical and chemical properties are completely different. Once the hydrogen atom is replaced by any other group, any other heteroatom, the compound newly formed is having completely different properties. But what if I speak about, suppose if I say it is CH3OH and C2H5OH. See, in these two compounds, both of them are having the same functional group. Both of them are having OH. That means, though their physical properties will be different, their melting point, their boiling point will be different, but their chemical properties will be same. What are chemical properties? Chemical properties are those which help you to determine the type of reactions the group of compounds may undergo. If two or more compounds have the same functional group, have the same type of bond, then they will have the similar chemical properties. That means the reactions that CH3OH will have, C2H5OH will have the same type of reactions. Chemical properties are simply judged by the nature of bond present and the nature of functional group present. If two compounds have both of, suppose if I give you two compounds X and Y, and both are having carbon-carbon double bond in them, both are having C double bond C, that means their chemical properties will be same. Chemical properties are judged by two conditions. One is the nature of bond, and the second factor is the type of functional group present. So that means, since CH3OH and C2H5OH, both of them are having same group OH-OH. So both of them will have the similar chemical properties. But yes, physical properties will be different. Chemical properties depend on the nature of bond and the type of functional group. But whenever it comes to the context of physical property, whenever you speak about physical property, in that case, the physical property will be different. Different compounds have different physical property. What are the physical property? Physical properties are like the boiling point, the melting point, the solubility, the water solubility, you can speak about that, etc. These are the various physical properties. And how do you judge the physical properties? Why are the physical properties different? Physical properties are different because the mass is different. The first thing, physical properties depend on the mass of the compound. If the mass changes, the physical property will also change. If not in a huge difference, but the physical properties are different. It may not vary very widely. It may not have very high difference, but they will be different. And next one is, they also depend on the number of atoms present. These two are related. If the number of atoms are different, obviously the mass will be different. So if mass is different, the physical properties will be different. See, for example, if I compare this to CH3OH, what can you see here? We are having one carbon atom 1 carbon atom, 4 hydrogen atoms, and 1 oxygen atom. Whereas C2H5OH, this is having 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom. So obviously that means if the number of atoms changes, the mass also changes. And if the mass changes, the physical property also changes. Now let's come back to the functional group. What are the various suffixes we use for the various functional groups? So now I have already taught you what are functional groups, and I have also displayed an image on the screen. You can see it, where the different suffixes for each functional group are shown. Like for example, we use oic acid whenever we have COOH functional group. Whenever we have carboxylic acid functional group, we include the suffix oic acid. Whenever we have aldehyde functional group, we use al as the suffix. Whenever we have ketone functional group, we use the suffix on. Whenever we have OH functional group, alcohol functional group, we use the suffix ol. So I have already provided you an image where different suffixes for each functional group is shown. Now, how to write the IUPAC nomenclature of such compounds? My first video is regarding compounds having one functional group. My next video will be regarding compounds having more than one functional group. Now, see, in this example, I'll be giving you some examples. I will solve them for you. So you will understand that any compound, any organic compound having carbon atom itself, any functional group like, for example, if we have carboxylic acid functional group COOH, if we have aldehyde functional group or ketone functional group, any functional group which itself has carbon atom in it will be considered as a part of the parent chain, and those will be included in the word root. And remember this sequence, this is very important. Functional group gets more importance than double bond, and triple bond gets the least importance. Functional group, any carbon atom carrying the functional group will be given lower locant. Carbon atom carrying the functional group will be given lower locant. I am solving some examples for you. Through that you will understand. Will be given lower locant. So let's solve some examples. You will understand through them. See, for example, number 1. Example number 1. See, in this compound we are having OH functional group. In this compound we are having OH functional group, which we say as the alcohol functional group. We say this as alcohol functional group, and we use the suffix ol for that. We are also having a carbon-carbon triple bond and carbon-carbon double bond in it. Now, how to number the parent chain? How to give locants to each of the carbon atom? So what will you do? If we number from the left hand side, it is 1, 2, 3, 4, 5 and 6. 5 and 6. That means the locants from the left hand side comes to be 1. At the 1 position we are having double bond. At the 4th position we are having OH. And at the 5th position we are having the carbon-carbon triple bond. But if we number from the right hand side, it comes to be, at the one position we are having carbon-carbon triple bond. At the third position we are having the OH functional group, and at the fifth position we are having the carbon-carbon double bond. So if you compare the left hand side and right hand side locants, what do you see? That the first locant is 1 for both of them. So let's skip to the second one. For the second locant, left hand side is 4, whereas the second locant from the right hand side is 3. So that means the right hand side is correct. And as I already said, the functional group, the carbon atom carrying the functional group will be given lower locant. That means the left hand side numbering is correct, is wrong. According to the left hand side numbering, at the one position we are having the double bond. At the fourth position we are having the OH functional group, and at the fifth position we are having the triple bond. And from the right hand side, at the one position we are having the triple bond. At the third position we are having the OH functional group, and at the fifth position we are having the double bond. As already said, the carbon atom carrying the functional group will get the lower locant. That means the right hand side numbering, in which the carbon atom having OH gets the third locant. According to the right hand side numbering, the carbon atom carrying the OH functional group gets the lower locant. That means the correct numbering is right hand side. The left hand side numbering is wrong. The left hand side numbering is to be omitted. Now let's check the numbering. Let's do it. This one is 4. So it is right hand side numbering is correct. The third position is OH. So it is like this. 1, 2, 3. Third position we are having OH. So the correct rule format, what is the format? Side chain. First we write the side chain. According to the side chain, there is no side chain here. After the side chain, we move to the cyclic part. There is no cyclic ring here. After the side chain, we write the cyclic group. Cyclic ring and side chain both are absent. So let's directly move to the word root. We are having 6 carbon atoms here. So that means hex. This is hex. And then we are having hex. Then at the fifth position we are having ene. Always the alphabetical rule has to be followed, alphabetical sequence. Hex 5 ene. Then it is 1 ine. Hex 5 ene, 1 ine, and 3 all. 3 all. Now you may question this, that ma'am, ine Y comes at the end. All O is before. So all is supposed to be written first. You may say that ma'am, it is hex 5 ene, 3 all, 1 ine. You may say this. According to you, this may be the correct one. Hex 5 ene, 3 all, 1 ine. But whenever you have the functional group, you are supposed to end the nomenclature with the functional group, with the suffix of the functional group. So though the ine Y comes later, what is the format? The format is side chain, then cyclic. After cyclic, we are having the word root. After the cyclic, we are having the word root. After the word root, we move to the ane or ene or ine. And from that, we move to the functional group. we don't write the functional group before. So that means after the word root, the in, ane or ine comes. So that means it is hex 5 in, 1 ine, 3 all. You should not write this as hex 5 in, 3 all, 1 ine. Simply follow the format that I have given in my previous video. Follow that so that you understand what is the format. Hex 5 in, 3 all, 1 ine is the wrong one. The correct one is hex 5 in, 1 ine. Hex comes under the word root. Hex comes under the category of word root. After the word root, we simply mention the nature of carbon-carbon bond. We are having carbon-carbon double bond. We are having carbon-carbon triple bond as well. Then we move to the functional group. That is all. 3 all. At the third position, we are having alcohol. And for alcohol, we use the suffix all. 3 all. Now, the next question. The next question is not having any functional group, but it is having a complex side chain. How to do it? I have shown you one example like this in my previous video. Just see, it is the side chain is the parent chain is somewhat like this. This is the parent chain of the compound. This is the parent chain. And the side chain is somewhat like this. These are the side chains. The ones that I have circled are the side chains. Are the side chains. And what are the side? Now let's number it and start writing the IUPAC nomenclature. Let's write the locants first. It is 1, 2, 3, 4, 5, 6, 7. So this is the numbering. The parent chain has 7 carbon atoms. If you see properly, the parent chain is having 7 carbon atoms. The side chain itself, the side chain, these are the side chains. These are the side chains. The side chain is having 3 carbon atoms. The side chain is having 3 carbon atoms. Now let's do it. So it is at the 4th position with the 4th carbon. With the 4th carbon, we are having the side chains. So what should be the IUPAC for this? 4, 4. Because at the 4th position, both the side chains are present. 4, 4, di. Because two side chains and of the same type. So di. And then what is the group here? The side chain is prop. Prop 1, prop 1, enyl. Prop 1, enyl. Because follow my previous video where I've already said that if the side chain is complex, then the carbon atom which is attached to the main chain is given number 1. That means these carbon atoms will be given the locant 1. Just a minute. So these carbon atoms will be 1. For naming complex side chains, the carbon atom which is attached to the main parent chain is given as number 1. And at the 1 position, we are having double bond. So prop 1, enyl. See, the side chain is having 3 carbon atoms. The side chain is having 3 carbon atoms. That is why it is prop. Prop 1, enyl. Then, after that, we are going for the word root. Word root is having 7, so it is hepta. Hepta. Hepta 2, 5 diene. 4,4 di prop 1 enyl hepta 2,5 diene, because at the 2 and the 5th position we are having double bond. See, the double bond position is at the 5th and the 2nd carbon atom, the lowest locant rule. So it is prop 1 enyl. I hope the complex naming is clear to you. The side chain is having 3 carbon atoms. The side chain is somewhat like this. See, it is having 3 carbon atoms. One here, and one here. 3 carbon atoms. The side chain is having 3 carbon atoms, and that carbon atom, the carbon atom which is attached to the main chain, will be given as the number 1. This carbon atom is attached to the main chain. This carbon atom is attached to the main chain. So it is given as 1. So prop 1 enyl. Now the third example is somewhat like this. See, what did I say? That the carbon atom itself having the functional group itself having carbon atom. See, for example, in this aldehyde, CHO is called the aldehyde functional group, right? And it is having carbon atom in it. The aldehyde functional group is having carbon atom in it. So it will be a part of the parent chain and will be included in the word root. So what will you do? How to number it? As already said, the carbon atom carrying the functional group will be given the lower locant. That means the aldehyde functional group will be called as 1. This is the first carbon. Then this one is 2. This becomes the third carbon, the fourth and the fifth carbon. The longest continuous carbon chain, parent chain, having the aldehyde carbon atom as well. So what do we see? That at the 4th position we are having a methyl group, and at the 3rd position we are having 2 chlorine groups. So now the numbering, after numbering, let's start the nomenclature. Then it is 3,3 dichloro. Why 3,3? Because at the 3rd position we are having 2 chlorine, and you need to mention 3 twice as well. On 3 dichloro is not correct. 3,3. 3,3 dichloro. Chloro C comes first, so dichloro. Then 4 methyl. 4 methyl. And then we are having 5 carbon atoms. After the side chain, we go for the cyclic. Cyclic is not there. So the word root. Word root, it is having 5 carbon atoms. So it is pent. Pent. Here no double bond or triple bond is present. So no need to think about ene or ine. So it is pentane. Pentane. And then at the 1 position we are having aldehyde. For aldehyde, we use the suffix al. So it is pentane 1-al. But as already said, the pentane E and al-A both are vowels. 2 vowels cannot be together. 2 vowels cannot be together. That is why what is done? It is pent-an 1-al or pentanal. 3,3 dichloro. 4-methyl pentanal. Now let's move to the 4th example. What do you see? There is no side chain here. Again as well, the carbon atom, this one is the functional group. So what happens? This is the 1 carbon atom having carbon atom. The functional group having carbon atom. 1, 2, then this one is the 3rd carbon, 3. This one is the 4th carbon, 4, and then 5. So what do you see? 5 carbon atoms, no side chain, no cyclic ring. So it is pent. Directly move to the word root. Pent. Pent. Then at the 3rd carbon, we are having triple bond. So pent 3-ine. 1 Al. Obviously, just according to the format. I'll discuss the format once again at the end of the class. Now, let's come back to the fifth example. What do you see? In the fifth example, this is an ester functional group. Ester functional group looks something like this. This one is R, C double bond O, O, R dash. The ester functional groups look something like this. How to understand this? With the oxygen atom, another alkyl group is present. And how do you write the name for such compounds? R dash attached to oxygen. The alkyl group attached to oxygen atom is named first, followed by the other group. So obviously, the alkyl group R dash, here R dash is this one. This one is R dash. And what is this alkyl group? This is ethyl. So obviously the ethyl will be named first. According to the IUPAC rule, whenever you write the nomenclature for ester, the group which is attached to the oxygen atom, the alkyl group attached to the oxygen atom is named first. So that means in this example, this is ethyl. So how do you write the name? It is ethyl. Ethyl. After the ethyl, we'll name the other part. That means this one is, start naming, this one is 1, 2, 3. This is carbon atom. The first carbon is, this one is carbon atom, so it is 1. That means ethyl, then 2 chloro. At the 2 position, we are having chlorine. So ethyl 2 chloro, prop, because 3 carbon atoms are there, so prop. Carbon-carbon single bond, so un. Propane, propane, because we are having all the carbon atoms are single bonded. There is no double bond here. So ethyl 2-chloropropane. And for ester, I have already told you that whenever you have ester, you have the O8. The suffix O8 is used. This is the suffix you use. Like for example, whenever we have aldehyde, we write al. Whenever we have ketone, we use on. For alcohol, we write all. Similarly, whenever you have ester, you use the suffix OH. So that means we are having ester here, so it is propane OH. Now see again, E and O, 2 vowels are adjacent to each other, which is not possible. That is why what do? We simply write as propanoate. Propanoate. Ethyl 2-chloropropanoate. When do we use the suffix OH? Whenever we have ester functional group. Now the next example, the sixth example is somewhat like this. Again, see, this is the carbon atom containing functional group 1, 2, 3, 4, 5, 6. So that means this is 3 amino. For NH2 group, we use the suffix amino. So it is 3 amino. Then no more side chain. It is 6 carbon atoms, so hex. 3 amino hex. 4 in. This one is the aldehyde functional group, CHO. This one is the aldehyde functional group, and that is al. So hex 4 in 1 al. 3 amino hex 4 in 1 al. So whenever you have NH2 functional group, you use the suffix NH2. Whenever you have NH2 functional group or NH2 group, then you write amino. Now the next one, the seventh example. Seventh example is somewhat like this. It is again an aldehyde functional group. This is again an aldehyde functional group. I hope you can understand this. This is CHO. So again, let's number it. 1, 2, 3, 4, 5, 6th carbon and the 7th carbon. What did I say? The functional group carbon atom will be given lower locant. In the beginning only it is said. So that means it is no side chain is there. So simply move to word root. Hept. Hept. Then it is hept 3 in. At the third position, double bond is there. Hept 3 in. 6 ein 1 L. No side chain is there. No cyclic ring is there. The format is simply like this. Side chain with the locant in alphabetical order. From that we move to cyclo. If any cyclic ring is there, we use cyclo. From that we move to word root. Word root means the number of carbon atoms in the parent chain. Then we move to N or in or I, depending on the nature of carbon-carbon bond. If you are having in or I, then you need to mention the locant as well. At which position? Like for example, third position in, so 3 in. Sixth position ein, so 6 ein. After that, we move to the functional group, suffix of the functional group. Suffix of the functional group. So these are the few examples that I have given. I will be discussing many more examples of this type in my next video. Stay tuned for that and like, share and subscribe if you like my video. Thank you everyone.